In this video, I will be discussing about covariance and correlation of negative relationship. Both covariance value and correlation coefficient R describe the relationship between the two numerical variables in terms of direction, but only the correlation coefficient R can describe the strength of the relationship between the two variables, because the covariance value does not give you the idea of the strength of the relationship. And because the correlation coefficient R is a standardized form of covariance, R does not change when we change the units of measurement of x, y, or both, while covariance value does change. This is because covariance value is very sensitive when you change the units of measurement of the variables. Meaning, if you have bigger numbers in your variable x, it will give you a higher value of the covariance. But if you have smaller numbers in your variables, then it will give you a smaller covariance value. So covariance will just give you the idea of the direction of the relationship. Because if the covariance value is positive, it gives you the idea that the relationship is positive. But if it is negative, it gives you the idea that the relationship is negative, meaning it has an inverse relationship. Now, unlike with the R coefficient, that it is a value between -1 to 1. So, if you have an R value of 1, the two variables have perfect linear relationship. But if the R value is 0.80 to 0.99, the two variables are having very high or very strong relationship. 0.60 to 0.79, high or strong relationship. But if you have an R value between 0.40 to 0.59, the relationship between the two variables is moderate. However, when the R value is 0.20 to 0.39, the relationship is weak or low. And if you have an R value of 0.01 to 0.19, the relationship is very low or very weak. And when the R value is 0, it gives you the idea that the two variables have no correlation at all. So when R and covariance are positive, the two variables have a positive relationship. But if the covariance value and the correlation coefficient are negative, then the relationship is negative, which means they have inverse relationship. Now, I have here an example of two variables, the social media time of 6 students and their corresponding test score. So, student A, who spent 50 minutes in social media, got a score in the test of 80, while the second student, who spent 30 minutes in social media every day, got a score of 89. So to compute for the covariance, let's compute first the mean. And to compute for the mean, let's add 50, 30, 25, 11, 45, and 7. And the sum is equal to 168. And we know that the mean has a formula of the sum of all these values divided by how many of them. So this is 168 divided by 6, because I have here 6 students. And 168 divided by 6 is equal to 28. So 28 is the average social media time for the 6 students. And to get for the average test score, we need to add also these numbers 80, 89, 85, 84, 82, 90. And the sum of this is equal to 510. So to compute for the mean, that's y bar is equal to the sum of all these numbers in the y variable divided by n. So the sum of all n, we know that's 510. Which is this one, divided by how many of them, and that is 6. So 510 divided by 6, the quotient is 85. So we have here 85. And to compute for the variance of the variable x, we have the variance of x having a formula of the summation of the square deviation of the every x value from its mean. And you divide it by n minus 1 instead of n, because we consider these 6 students as a sample of all the students. So to get the variance, we need to fill up this column that every x we subtract the mean of 28. So we have 50 minus 28 here. And also 30 minus 28. And then 25 minus 28. And 11 minus 28 here. And also 45 subtracted by 28, and also the last number, which is 7, subtracted by 28. So if you get the difference, we know that the difference of this one is 22. 30 minus 28 is 2. 25 minus 28 is negative 3. And this one is having a difference of negative 17. And also this one is positive 17. And 7 minus 28 is negative 21 here. And if you square this 22, we've got a number of 484. And squaring 2, which is 4, squaring negative 3, which is 9, and negative 17, when you square, that's 289. And also this one, 289. And the square of negative 21 is 441. Now take note that the square of a negative number is always positive. So if you add 484, 4, 9, 289, 289, and 441, it will give you a sum of 1,516 there. So to find the variance of x, we get the sum, which is this one, the sum of the square deviations of these values of x from its mean, 28 here. And the sum is 1,516. And if you divide it by 6 minus 1, you've got a number which is 303.2. So this is the variance of the variable x. Now let's compute for the variance of the variable y. So the variance of y is equal to the sum of the square deviations of every y value from its mean divided by n minus 1. So to get this variance of y, we just subtract every y by its mean. So we have here 80 minus 85 here, and also 89 minus 85, and also 85 minus the mean, which is also 85, and also here 84 minus 85, and here 82 minus 85, and then 90 minus 85. So if you get the difference of 80 and 85, you've got a number which is negative 5. 89 minus 85 is 4. 85 minus 85 is 0. 84 minus 85 is negative 1. And 82 minus 85 is negative 3. And also this one is 5. And if you square this negative 5, we've got a number 25. The square of 4 is 16. The square of 0 is 0. The square of negative 1 is 1. And the square of negative 3 is 9. The square of 5 is 25. So adding this 25, 16, 0, 1, 9, and 25, get a sum of 76. So that's the sum of the square deviations of every y from its mean of the variable y, which is 76. And divided by 6 minus 1, we've got a value which is 15.2. So therefore, the variance of the variable y is 15.2. Now we can compute at this time the covariance of the two variables. So the covariance of these two variables, x and y, is equal to the sum of the product of the division of x from its mean and the division of y from its mean here. And we divide it by n minus 1 because we consider again this 6 students as a sample of students from all the students. So we just multiply the value of x minus x bar and y minus y bar. So 22 times negative 5, that is negative 110. 2 times 4, which is 8. And then negative 3 times 0 is 0. Negative 17 times negative 1, positive 17. And 17 times negative 3 gives you a product of negative 51. And then negative 21 times 5, that is negative 105. And if you add all these numbers, you will get a sum of negative 241. So the covariance of the two variables x and y is equal to negative 241 divided by 6 minus 1. And this gives you a covariance value of negative 48.2. So this gives you the idea of the relationship, that the relationship between these two variables is negative. So they have a negative relationship, meaning an inverse relationship. So in simple words, as you increase the social media time, the test score decreases. And as you decrease the social media time, the test score increases. So that's the negative relationship as indicated by the covariance value, which is a negative number. But the absolute value of 48.2 has no meaning, only the sign which is negative. So if the covariance is negative, then the relationship is negative. But this 48 has no bearing, no meaning, which means that it doesn't give you the strength of the relationship. So it does not mean that if you've got a bigger number, the stronger the relationship. And when you get a negative number, then you will have a lower relationship. And we can now compute our R coefficient between the two variables x and y at this time, because we have the covariance of the two variables here, and then we divide this one by its corresponding standard deviation values. So the standard deviation of x multiplied by the standard deviation of the variable y. And we know that the covariance between these two variables is negative 48.2. And this will be divided by the standard deviation of the variable x, which is the square root of its variance. So we have the square root of 303.2 times the square root of 15.2, because 15.2 is the variance of the variable y, and the square root of the variance is the standard deviation of the variable y. So we have negative 48.2 divided by the product of these two numbers, and the product is 67.887. And we have the quotient of negative 0.71. So this is the correlation coefficient of the two variables x and y, which means that since the correlation is negative, then the relationship is negative between these two variables. And this will not only give you the direction which is negative, but gives you the strength of the relationship. So this value of 0.71 belongs here. So therefore, the relationship is high. So it has a high relationship, or having a strong relationship between the social media time and the test score of the students. So in summary, the R coefficient and the covariance value, both numbers are negative. Why? Because the relationship is negative. But the 48.2 has no meaning, only the sign of the number that gives you the direction. And so with the R, but it is only R that can give you the strength of the relationship based on its value, because it's a standardized form of a covariance value. So the closer the value to 1, the stronger the relationship. And the closer the value to 0, the lesser is the relationship. So let us plot the data points in a scatter plot. So when the social media is 50, the test score is 80. So 50, that is 80. So it's here. So this is our student A. And then for 30 minutes, 89 is the test score. So 30, and then the test score is 89. So this is our student B. For 25 minutes, 85 is the test score. So 25, you will have 85. So this is our student C. And then student D is 11. 11 minutes, 84. So somewhere here is our student D. And then 45 minutes, 82 is the test score. So where is 82? 82 is somewhere here. So this is our student E here. And then for 7 minutes, the test score is 90. So 7 somewhere here, and then 90. So this is our student F there. And as you can see, the points are having a pattern that is approximating a straight line here. A straight line that is sloping downward. So we can draw a line that best fit these data points here. So this is the line that approximates the pattern. And you can observe that the line is sloping downward, which means that as you increase the value of X, the social media time, the scores are decreasing. And as you decrease the social media time, the test score of the students are increasing. So there is an inverse relationship. When you increase the value of X, the value of Y decreases. But when you decrease the value of X, the value of Y increases. So that's why the pattern of the relationship is inverse. So the line of pattern is decreasing as you move to the right. And that's it. If you learned something today, please check out my channel for more videos like this and click subscribe. Click the notification bell below so you'll get notified whenever I'll be posting a new video. Don't forget to like this video to show your support. And always remember to math your way up. Thank you.